Determining whether a linear function is increasing, decreasing, or constant. The linear functions we used in the two previous examples increased over time, but not every linear function does. A linear function may be increasing, decreasing, or constant. For an increasing function, as with the train example, the output values increase as the input values increase. The graph of an increasing function has a positive slope. A line with a positive slope slants upward from left to right, as you can see here in figure A, which is an increasing function. Now for a decreasing function, the slope is negative. The output values decrease as the input values increase. So a line with a negative slope slants downward from left to right, as you can see in figure B. Now if the function is constant, then the output values are the same for all input values, so the slope is 0. So a line with a slope of 0 is horizontal, as you can see here in figure 5C. Now increasing and decreasing functions. The slope determines if the function is an increasing linear function, a decreasing linear function, or a constant function. The first scenario, f of x is equal to mx plus b, is an increasing function if m is positive, meaning it's greater than 0. F of x is equal to mx plus b is a decreasing function if the slope is less than 0, meaning that m is negative. Now, f of x is equal to mx plus b is a constant function if the slope is equal to 0. Now, example 2, deciding whether a function is increasing, decreasing, or constant. Now, some recent studies suggest that a teenager sends an average of 60 texts per day. For each of the following scenarios, find the linear function that describes the relationship between the input value and the output value. Then determine whether the graph of the function is increasing, decreasing, or constant. So for part A, the total number of texts a teen sends is considered a function of time in days. The input is the number of days, and the output is the total number of texts sent. So the function would be f of x, which is equal to 60 times x. So the function can be represented in that way, where x represents the number of days. The slope 60 is positive, so the function is increasing, and this makes sense because the total number of texts increases with each day. For part B, a teen has a limit of 500 texts per month in his or her data plan. The input is the number of days, and the output is the total number of texts remaining for the month. So we would have f of x, which is equal to 500 minus 60x. So that's how the function can be represented, where x represents the number of days. And in this case, the slope is negative, so the function is decreasing. This makes sense because the number of texts remaining decreases each day, and this function represents the number of texts remaining in the data plan after x days. In part C, a teen has an unlimited number of texts in his or her data plan for a cost of $50 per month. The input is the number of days, and the output is the total cost of texting each month. So f of x is going to equal 50. The cost function, that's how it's represented, because the number of days does not affect the total cost. The slope is 0, so the function is constant.